Good morning, good evening, all. On behalf
Morning.
of on behalf of the President of PAASE, Dr. Mario Santo Domingo, following greeting protocols, I'd like to welcome the officers and members of PAASE, NAST, NRCP, DOST, UP ERDFI, National Innovation Council, and other groups, including startups and the general public, to the inaugural event of PAASE for Philippine Innovation Fireside Chats. And I am Gisela Concepcion, Professor Emeritus of UP, and currently serving as an executive member of the National Innovation Council. We know that innovation is a major driver of socioeconomic progress. And we have already presented in the videos the background on the NIC and PAASE's commitment to innovation. And today's event is the inaugural event. And I deliberately selected our speaker today because of the cross-cutting impact of the innovations in this government agency that he leads. Subsequently, the fireside chats of PAASE for Philippine Innovation will feature innovators from academe and RDIs, from MSMEs, startups, large industries, those silent running innovators as well. Also TBIs, accelerators, and venture capitalists, and also from media who support innovation and science and technology passionately. And so at this point, I would like to introduce my co-host, who will introduce our guest speaker today. Dr. Alvin Colaba of De La Salle University is Distinguished Professor of Mechanical Engineering and a University Fellow. He's an energy scientist and technologist. He's the pioneer of life cycle assessment in the Philippines, Vice President of the National Academy of Science and Technology, reviewer and monitor person of PICARI and STRIDE projects, past president of the NRCP, and past president of PAASE. Dr. Alvin, the floor is yours.
Fed?
Yes, Doc, we can hear you now.
Okay. Again, thank you very much, Giselle. We're very much excited in this inaugural edition of our Philippine Innovation Series organized by the Philippine American Academy of Science and Engineering, which is a series of fireside chats. So today we are really honored to have our distinguished speaker for our inaugural edition. Okay. We have Dr. Joel Joseph S. Marciano. Next slide, please, Feb. He is the first Director General appointed by the President of the Republic, at the time, former President Duterte, to head the Philippine Space Agency. He served as Director of the Advanced Science and Technology Institute of the Department of Science and Technology prior to his appointment with PhilSA. Dr. Marciano obtained his BS in Electrical Engineering from University of the Philippines, Diliman, and his PhD in Electrical Engineering and Telecommunications from University of South Wales in Sydney, Australia. He also served as a former director of the Electrical and Electronics Engineering Institute of UP Diliman, a JSPS Fellow at the Tokyo Institute of Technology in Japan, a UP Dado Banatao postdoctoral fellow at the Berkeley Wireless Research Center in the University of California, Berkeley, and at the School of Electrical and Computer Engineering at the University of California, San Diego in 2004 and 2005, respectively. He's also a renowned scientist in the field of electronics and communications. Ladies and gentlemen, we are proud to have him today, the Director General of the Philippine Space Agency, Dr. Joel Joseph S. Marciano, Jr. Joel, the floor is yours.
Thank you, Dr. Alvin, for that kind introduction, and thank you to the Philippine American Association for Science and Engineering, for Advancement of Science and Engineering, for having me. I am truly honored and privileged to be the inaugural resource person for PAASE for Philippine Innovation. And I will get to my presentation. Frankly, I have 20 minutes. There's so much to talk about. I'm not sure. I tried my best to fit it in, but let's get started. So let me share the presentation. Thank you also to Dr. Giselle Concepcion and everybody, all those watching this morning or afternoon or evening, wherever you may be. Yeah. So we have the slides on that. Okay. So the title of this presentation is AKYAT Pilipinas, Angkop sa Kalawakan, Yari at Tatak, translated to suitable for space, built and branded in the Philippines. And it's a slogan. It's really our battle cry when we build these space capabilities. The question is, can we build for outer space in the Philippines? And hopefully with this presentation, I can give some insights into the answer. Of course, we have an answer for this, but the audience can also give us their assessment and their feedback as to this endeavor. Let's go to the next slide. Let me give a quick introduction of the Philippine Space Agency for those of you who might not have heard of it until this point. The Philippine Space Act was signed on August 8, 2019 by then President Duterte, which established the Philippine Space Policy and the Philippine Space Agency. The short name is PhilSA, not PSA, right? Because that's already taken. That's the Philippine Statistics Authority. So it's PhilSA. It's a common, misconception that it's somehow attached to DOST, or Department of Science and Technology. It is not. The prior versions of the bill, some versions of the bill actually had it under DOST, but eventually what came out of the woodwork in Congress, Philippine Congress, is that it's under the Office of the President, and there is a Philippine Space Council. Now, PhilSA is the central government agency that addresses all national issues and activities related to what the Act calls Space Science and Technology and Applications, or SSTA. Next slide. So then RA 11363, I mentioned, establishes the Philippine Space Policy and the Philippine Space Agency. And among other things, what the Philippine Space Policy entails is that, well, it embodies the central goal of the country to becoming a space-capable and spacefaring nation within the next decade. And under the framework of the Philippine Space Policy identifies 6 key development areas. You see there in the hexagons: space science and technology applications, supporting national security and development, space research and development, space education and awareness, international cooperation, hazard management and climate studies, and space industry and capacity building. So I guess that last one would be the focus of this presentation. Next slide. I mentioned the Philippine Space Council. This is the principal advisory for the coordination and integration of policies, programs, and resources affecting SSTA in the Philippines. This is also created by law, the Philippine Space Act. It's chaired by the President. The vice chairs are Cabinet Secretary, Secretary of Science and Technology, Secretary of National Defense, and you see the other members there. Different members of the cabinet, and also the chair of the Senate and House Committee on Science and Technology. Notably, you would expect that for space, you'd have agriculture there, and environment and natural resources, but also you see foreign affairs, ICT, NEDA, finance, and trade and industry. PhilSA Director General is the head secretariat of this council and also the presidential advisor on space matters and holds a cabinet rank. Now, we are, as the chair of the Philippine Space Council, we are guided by the words of the president. During the 77th UN General Assembly, he mentioned the following: the Philippines is preparing for the future by laying the governance framework that will allow us to pursue digital solutions towards a more modern economy and expand our presence in outer space. He added that we need to start by defining the norms of responsible behavior in cyberspace and outer space and forming legal rules that will prevent the weaponization of artificial intelligence. Next slide. So guided by these words and the mandate in the Philippine Space Act, we formed our mission, and that is value creation. That is at the core of the PhilSA mission. Particularly, we will promote and sustain a robust Philippine space ecosystem that adds and creates value in space for and from Filipinos and for the world. And next slide. To accomplish this mission, we use the framework of the space value chain. So the space value chain is this composed of components and their nexus, which when manifest and working together, yield socioeconomic benefit and value from space at the end of the chain. There are different components of this, but the focus, if you click on that, the focus of my talk this morning is on satellites and upstream infrastructure, the first part of the chain. Now, being able to master this component, satellites and upstream infrastructure, enables also the other parts of the chain. Sovereign capability in space means that you have control of the data, its accessibility, availability, and suitability, among others. So that's our focus for this morning. I would love to talk about the other components of this chain, and I have in various occasions, but given the topic on hand, this is really the focus for now. So yeah, our goal is really to build strength in each component of this chain domestically and seek international cooperation, capacity building, and policies that will support the strengthening of each part of this chain towards creating socioeconomic value and benefit at the end. Next slide. And so we begin. Well, to be a spacefaring nation, as the law and the Philippine space policy mandates, means having sovereign capability in space. I mean, we have to fulfill what the law says, and that's to be a spacefaring nation and space capable one. That could mean spacefaring could mean, of course, having rocket launching capability from within one's own shores. But at the very least, in my view, it means having satellites, sovereign satellites, ones that you control yourselves. So that has kind of begun. So if you click on that, you have Diwata 1 in the PHL Microsat program in 2014, followed by the Stamina for Space program in 2018, and now PhilSA, the Philippine Space Agency, taking over 2020 onwards, building on top of these prior programs of the DOST. Many of us were involved, from PhilSA, were involved in these prior projects. So what this meant is that we were building these satellites, Diwata 1, Diwata 2, and the Maya Nano satellites. In fact, in Diwata 2, there were two components in that satellite that were localized. That means contributed from local sources, an amateur radio, an attitude sensor. And with Stamina for Space, the focus was on being able to localize key payload and bus components, key components in the satellite. The bus refers to the electrical, mechanical structure and components of the satellite. The payload, obviously, with the main instruments, whether it's a radio or a camera that's on board that fulfills the mission. Mayas, the Maya CubeSats, were designed and assembled locally. And PhilSA taking over will, of course, will increase the content of the local content in that satellite to maybe 9 locally developed components to be tested in flight. So are we really building satellites? Please click. Are we really building satellites? Well, not necessarily. What we are really targeting by building these systems is that we're targeting space capabilities, which when we master leads to high value local skills and high value industrial capacity. Next slide. Why is it special? Because space is harsh. Please click. You have all these conditions in space: vacuum condition, deep space radiation, solar radiation, plasma environment, temperature fluctuations when you're facing the sun or when you're eclipsed by the shadow of the Earth, Then the temperature fluctuates. You have orbital debris, which you may need to maneuver and navigate against. So all these conditions exist in space, which are not present on Earth. So it's tough enough to build things for Earth reliably, but building something for space reliably requires additional testing, additional skills and capabilities. We can discuss all of these things in a different lecture, and there are people here eager to talk about these conditions. But for now, just a pretty high-level treatment of this consideration. So building for space means developing the discipline to build highly reliable systems that has to work, because you can't, if something goes wrong, you can't really go back and fix it. So that enables our engineers, Filipino engineers, to build things for other difficult environments, like deep sea environments, like mining tunnels, geothermal wells on Earth. So that's the skill that we're trying to instill. Okay. Next. Now this is a very heavy slide, and it, by itself I can spend 1 hour, but let me try to compress it. You talk about technology readiness levels, or TRLs. The TRLs are a way of measuring how mature a new component is. In this case, for space, these components, as I mentioned, are built by universities or industry working with industry teams. TRLs range from 1 to 9, where 1 means the component is just an idea, and 9 means the component is ready for use in the real world situations. And of course, you should try to sell it. You should try to market it already. TRLs help us assess the risks and benefits of using new components in space missions. You saw in the previous slide how that's a very harsh environment, so you just can't use any component from working on Earth and put it on a satellite and expect that it will work. You have to test it against certain conditions. Now, to increase the TRL of newly developed components, and I emphasize, we want local industries to be developing these components, working with universities. We need to test them in a simulated space environment or through a technology demonstration mission, such as the Maya. You see there, the Maya CubeSats. These are small satellites that can sit on the top of your hand. You can hold it like this, but by itself, you think it's not very capable. But no, it's really useful because you can put components there, small components, individual components built by universities, built by students, or built by companies in the Philippines, and test it in an actual space environment. So in other words, by building the satellite, you're opening the door to space for Philippine industries and Philippine universities in a more cost-effective way. Okay, so if you're able to do that, you're able to put it on a satellite, you're able to demonstrate it in space, you bring this technology up to TRL 7. Now, of course, you can go back because you've demonstrated it, and then you build another unit, this time what's called the flight unit, which you subject it to space qualification using testing facilities on Earth, like a vacuum chamber, temperature cycling, vibration tests, because the thing has to go on a rocket, and you don't want screws falling off when it's put on a rocket, because of the strong vibrations, and other tests like radiation. Then you fly it, and when you fly it and you're able to achieve an operational mission, that component and that satellite gets to TRL level 9, and that is what we call the phase where you have space heritage. So then this component, when it fulfills an operational mission in space, you can now reproduce it on Earth and produce it many times, mass produce it to the exact same specs. You don't even need to test it again, and you can start selling it, and you can start using it, face outwards towards the rest of the world and sell these components, be in the supply chain, the global supply chain. And by the way, they're not building 1 or 2 satellites. Countries and companies are building thousands of satellites now in low Earth orbit. There are about 9,000 satellites orbiting the Earth, and I think more than half of that is SpaceX. I think so. It's a considerable. There's volume in space, and at low Earth orbit, these satellites have a certain limited lifetime. They go back or deorbited, and they burn up, and you have to replenish them. So somebody has to keep building these satellites to replenish that constellation. And we don't want the Philippines missing the boat. This is one pathway for industrialization for the country to be part of the global supply chain for space, which is about $40 billion at the moment in the global space economy, according to some reports, the upstream part of space. Now let's go to the next slide. When you see, this is an exploded view of Diwata-3. That's probably what you see here, an exploded view of a satellite. But what we actually see here are opportunities, opportunities for industry building and for strengthening local industries. So you have the different components there from structure, payload, sorry, go back, not yet, from power, propulsion, thermal, payload, RF subsystems, attitude and orbit control systems, flight software, onboard data handling, structure and deployables. One of our slogans is we put computers in orbit because really a satellite has several computers in them. And that kind of helps demystify satellites because you know how useful a computer is on Earth. Imagine having one in space or having several in space that's doing computing for you, that is equipped with sensors and giving you data from that strategic vantage point. And what we did in this diagram is for each of these subsystems, you see that we mapped it to certain industry sectors: materials engineering, fabrication of metal products and manufacturing, optical instruments and photographic equipment manufacturing, electronic products manufacturing, embedded systems and software development, solar and battery engineering. And we are in discussions with the Department of Trade and Industry trying to build up these capabilities and promote these capabilities as well. In the strategic investments priorities of the policy of the Philippines, SIPP, manufacturing for space is one of those that are incentivized in that SIP, in the priorities plan. So click on that. We've already started here. So highlight, you see the ones with the red borders. These are subsystems, so we're already engaging various levels, various extents, different companies here in the Philippines, building power systems, structures and deployables, onboard data handling, flight software, attitude control system, payload. Attitude and orbit control system, this is the system that orients your satellite because you're carrying a camera. We take it for granted that you're taking a picture from 400 or 600 kilometers away. If you're off by a fraction of a degree, then you fail your mission because you're not taking a picture of the right place. So this has to be very precise. And there's a lot of very important software in there that runs those algorithms. Okay, let's go to the next. And so with Diwata-3, these are the new developments. Just click through all of that. You see scientific payloads, experimental science and engineering payloads, and you see the satellite structure itself. A bit later, just a few slides from now, I will talk about what's locally being built here. So you see how these components fit into the satellite, where they're placed. There are engineering constraints in terms of weight, in terms of volume, in terms of power consumption. You can't really put so many cameras there, and you can't really run so many things at the same time because of constraints on computation of energy or power, and also mechanical constraints. Now, you see a satellite like Diwata-3 carries several cameras. That's because its mission is partly technology demonstration. You want to be able to demonstrate these different cameras, and you're demonstrating them not for the sake of, for a trivial pursuit. No, it's really to help local companies and help local universities get to space, build reliable products, get that skill, and then build more of them so that we can be in the global space economy. So payloads are certainly important, and also the onboard computers are certainly important. Next slide. Now this diagram shows the different blocks. It's a bit busy, but let me walk you through it. You see numbers, first of all, there. You see a legend. The numbers on the top right represent the technology readiness levels of different components. And many of them are already TRL-9. That's because we've used them in previous satellite missions. They've already worked. They proved their worth. So they're already TRL-9. But what is more important here are the ones which are in, I think the ones in green, right? Okay. I'm not sure if you can see actually the green. Components in green are being developed locally. So I'll highlight them one by one. Now, blocks shaded in blue are re-engineered. So let me let me walk you through some of these. Okay, next slide, just click. You see, first of all, okay, click please. There. The first component being developed locally is SINAG. This is solar inertial navigation and geomagnetic sensors. This is part of the attitude control system of the satellite, the system that controls its orientation. You have all sorts of sensors here. And SINAG, working the teams, the engineering teams from the universities and working with PhilSA engineers are developing this by working with companies. In particular, you have here NSB Engineering, fabricated the mechanical enclosure for this. So that's not trivial as well because of the mechanical constraints in the satellite and also vibration. All right. You see, next click please. You see CPAT is also NSB fabricated the mechanical assembly of this. This is the, sorry, I have to zoom in, the star imager for precise attitude tracking. I think many things have not changed in terms of how we navigate. We still look at the stars and we have a constellation map and to guide us as to where we are. And a satellite is no different. You know, it looks at the stars to try to find out where it is. So we use a camera like that, a star camera, tracking camera on the satellite as part of the finer precision attitude determination and control system. Next. UTAC, very appropriately named, is the unit for telemetry acquisition and command handling. This is an onboard computer that handles the telemetry data and processing the commands from the ground, right? We have companies, SmartFox Data Solutions, develop FPGA IP cores for that, and PyTos fabricated the PCBs for UTAC. Remember, this has to go to space, and we brought these things up. You see the numbers there up to TRL4. Of course, this should progress when we put it on a satellite and test it in orbit. Next. USAP is the amateur unit for satellite amateur radio payload. This is an amateur radio payload that is used to communicate with the satellite in times of emergencies on the ground. When the telco infrastructure goes down, you put a radio there where you can send messages to a satellite, ask for help or do some reporting or even talk to somebody. So it's voice and data, simple data communications. You have companies there that are helping out in building this system. Next. You have Malikmata. Malikmata, well, this is work of teams in the university, Dr. Jing Soriano and her team in optical building camera, multi-application line imaging camera, a monochromatic and trilinear array. And you have companies that are engaged in building this, local companies here, in fabrication of the printed circuit boards and the mechanical assembly of the satellite. Next, of that component. You have HUSAI. HUSAI is handling unit of satellite scientific apparatus and instruments. So this is the computer in the payload section that controls all the cameras. So that's HUSAI. Again, you have companies we're working with companies on the firmware. That means the embedded software in that computer, right? It has to work in that kind of environment, and also on the printed circuit board and the electronics of that subsystem. Next. You have Galaw. Galaw is guidance, attitude, location, and actuation work. You have NSB and SmartFox contributing to that effort. And then you have, okay, next. PAN is a panchromatic camera, and there's a company in Cavite that helps fabricate the mechanical assembly of this camera. Next. And so, well, we've run through those examples. Now, those are not really drawings. Those are things that have been done. So you ask the question, so can we build for outer space in the Philippines? I guess the answer is, well, yes, we kind of already have, by looking at some of those components that have reached a higher TRL level, and some of them going up to higher TRLs. This is captured in a broader effort of PhilSA called Industrious. It's really taking space adjacent companies in the Philippines. We don't have space industry. I mean, we have aerospace companies here that are probably more aero than space, but full-fledged space industry, not yet. But what we have are space adjacent companies, semiconductors, electronics, machining, materials, fabrication. And what we're trying to do is handhold them, cross the chasm, bring them to space qualification, and then turn around, face the rest of the world, and start engaging companies that are building large satellites. So it's not necessarily Philippines building satellites. Of course, we can, because if we build this capability, but you can supply these components everywhere else and be in that entire supply chain. So this is an effort that we're doing with these companies and DTI, of course. Next slide. These are some of the companies that are participating, and we appreciate their support because it's not really free. Even though we offer these trainings and these capacity building activities at no cost, it comes at a cost to them because they have to pull out their engineers from the factory floor to attend the sessions with PhilSA engineers, and then exchange know-how, and to converse. So we appreciate the support of these various groups for our projects. Next. And so finally, here we are. I use this slide. This is from Professor Mengucho of Kyushu Institute of Technology, and he illustrates what he calls an infant space ecosystem. That's pretty much, if you want to find something to describe where we are, we're that. We're an infant space ecosystem, and that's characterized by the space agency kind of doing everything, carrying the heavy lifting, and that's typically government. Business development, operation and data service, engineering, science, human resource development, public relations, even policy and international cooperation. You see the key development areas of PhilSA, that's all covered. And that pretty much reflects where we are trying to build an infant ecosystem. Trying to build from an infant ecosystem where government does the heavy lifting, government does pretty much everything, into, next, a more mature space ecosystem where the space agency kind of consolidates and says, okay, well, I will just hold the baton and orchestrate the activities of these groups, like a space industry now that is serving customers, perhaps not so much, but then really you see the bold arrows, the customer is still government, right? But then you have industry serving government. You're also able to support universities with grants now that are doing space activities. And you're also serving the data needs of other government agencies for satellite images, etc. That's more mature. Then you're just coordinating, facilitating, supporting, not really doing things that can be done already by industries or universities and government. Okay, but there is also a very mature space ecosystem. If you click and you see now the bold lines there, wherein the government starts becoming less of a customer for industry, and now private industries will face, of course, other customers. They can start selling to other groups other than government, and then you strengthen the linkage between with the space agency holding the baton and facilitating and coordinating. It now strengthens the linkage between industries and universities even more, right? So that's where we're trying to head. And by building these systems, it's not a question of just copying, or the Philippines just trying to copy what everybody else is trying to do. No, we want to be able to get to a point where we have vibrant industries, vibrant universities, building with high value capabilities, and building up the economy of the country in this area, in the industrialization. Next slide. Okay, so I will end by just hopefully this takes 2 minutes by sharing this video.
When the Philippines began building satellites, we started small, as small as a suitcase. Yet the stakes were high and the challenges were great. After the success with 6 of these small satellites, the Philippines is ready for something bigger. In December 2020, the Philippines kicked off the Multispectral Unit for Land Assessment, or MULA satellite project. Weighing around 130 kilograms, MULA will carry a true color camera that can capture higher resolution images, covering around 73,000 square kilometers of our country in one day. Data from MULA satellite will be used for addressing food security, disaster resilience, environment conservation, and protecting our national sovereignty. The Department of Science and Technology jump-started the funding of MULA. The project was jointly implemented by the DOST, Advanced Science and Technology Institute, and the University of the Philippines, Diliman, in coordination with the Philippine Space Agency, or PhilSA. 16 Filipino engineers who underwent a know-how training and transfer program in the UK are involved in building the satellite and are now part of PhilSA. The training capacitated our homegrown engineers, not just with knowledge, but the license to build more local commercial satellites in the future, leading the way for the creation of a robust and thriving space industry to support the country's space program. PhilSA will oversee the completion and launch of MULA and manage its operations. MULA in Ilocano means plant, pointing to the satellite's mission on food security. In Tagalog, it means point of origin or beginning, which symbolically signals the Philippines' foray into a new era in satellite development toward the vision of a nation bridged, uplifted, and empowered through the peaceful uses of outer space.
Thank you very much,
So,
Director
I
General.
just want to acknowledge Dr. Giselle, just last slide, I think, I acknowledge the, the people who were who helped in that presentation. But anyway, I can acknowledge them later. But please go ahead. Yes, thank you.
Thank you so much. So, in the interest of time management, we would like to say that Dr. Joel needs to leave for a last meeting in the PICC, and so do I. So the way we will do this is for Alvin and myself to ask two questions, and the general guide would be in this conversation would be shown here, but I will then articulate some specific questions followed by Alvin. Afterwards, we will open the floor to our guests, and we would encourage everyone to keep the question simple and not complex, just one, two statements, so that we can give a chance for everyone to speak and for Joel to answer the questions. Most certainly, we will invite Joel to speak again on all the developments and interesting outputs of the PhilSA. So, Joel, I understand you are on a mission to develop high-value local skills and competencies. So that alone is a major innovation area, which is in education. Okay, but then we know that PhilSA satellites are already impacting on the other major areas of concern in our country today, which would be climate change. And today we have the problem of rains and flooding. And then always in the papers, you would have, of course, agriculture, fisheries, and food productivity. So I would like to know in brief what the PhilSA is contributing to addressing these two main areas of concern. I will follow with a second question, Joel. Thank you.
Yeah, thanks for that question, Dr. Giselle. That's the downstream part. Now, that's a very big part of our activities. And our flagship program there is called Space Data Mobilization. We coined that term, really, the mobilization of space data. And just very quickly, you know, these activities are captured in the agreements that we've signed most recently with the Department of Budget and Management, with the Department of Agriculture, Bureau of Fisheries and Aquatic Resources, with the Mindanao Development Authority, even with Land Bank of the Philippines, on how to use satellite images to help guide their decisions and their programs. In that value chain, which I was not able to elaborate on, a crucial part of that value chain, you might be building all these capabilities, satellites and data and ground stations and high performance computers, but the value of death there is the impetus and resources to act on the data. And that's why these partnerships are crucial. We are just a space agency. We're not the disaster, we're not the environment specialists. You know, these are other departments. So we have to work with them, and we are. So that's my answer in a nutshell. You know, it's working with them and giving them additional tools. DNR, we signed on MOA there, and one of the highlights of that worked so far is DNR has been able to use satellite images to shut down an illegal mining operation in Mindanao. That's the power of the view from space. And we have to seize control of this capability. We have to master this capability up to the technology components that generate the data, because that's seizing control of our future. Hopefully that answers. By the way, I don't have to leave right away, Dr. Giselle, because my appointment at NAST is still in the afternoon, so I can stay longer for questions. I know you have to go early, but I can stay longer. Thank you.
Thank you, Joel. So, ladies and gentlemen, there's an ongoing deep conversation within our PAASE Google group about building capabilities. And there are PAASE scientists who are very much into UAVs and development of MEMS. And actually, Joel is challenging them to contribute directly to the development of our capabilities here. So I'm glad about it, because now in PAASE, we are engaging in conversations that are directly relevant to our country's problems. And Joel, you are at the forefront. And so I'm so glad to have nominated you to PAASE. Anyways, I think my second question has to do with the existing drones and satellites that we have here today. The very famous new entrant, of course, is Starlink. And I know he's controversial, but Elon Musk is my scientific and technology idol. And I know that he had been wanting to do this in parts of the Philippines like Bataan, but now he's available. But also recently you were on the cover of PhilSA yesterday, Joel, and you announced together with the president and the DTI secretary and the DICT secretary the entry of Singapore-based Pacific KU satellites 1, 2, or 3. And so how do these contribute to our space and satellite capabilities? What are their resolutions and precisions? What are their applications in terms of ICT and education and all this in relation to Maya and to Duwata?
Thanks. Yes, the satellites come in different shapes, sizes, and functions. Some satellites carry cameras. Basically, they're differentiated by their payloads. So when a satellite carries camera, typically it's for surveillance or Earth observation, or maybe a sensor for the weather. Some satellites carry radios, high capacity, high speed radios, and we can use them for connectivity as relay links. They're called bent pipes, because you have somebody from the ground connecting with the satellite, and then the satellite simply relays that signal to another part on the Earth to connect the 2 points. So it's a bent pipe. These satellites of Pacific and Starlink, they are telecommunication satellites. They are internet satellites. They don't have cameras to take pictures of the Earth. But what's changed recently is a lot of these satellites are now in low Earth orbit. Even well, of course, with cameras on satellites, you want to be closer to the Earth to take finer pictures. But with internet satellites, traditionally they are at geo orbit, as opposed to 600 kilometers, which is low Earth orbit. Geostationary orbit is at 30,000 kilometers, so over the equator. And so it's considerably far. But what has changed is that some of these satellites are now at low Earth orbit, 4,000, 5,000 satellites in low Earth orbit, providing internet connectivity globally. Now, these satellites are complementary. Of course, one is for connectivity, one is for getting data. But data needs to be, of course, they both support digital transformation. One with the pipes, for connectivity, the other for the content, which is satellite imagery that could be processed and value added for many applications. Mentioned agriculture, maritime domain awareness, defense and security, environmental protection. So they're all part of this ecosystem. And I think for a country where we are, as an archipelago maritime nation, situated geographically where we are, it just makes sense to have these capabilities and have access to these and control our fate. In other words, in terms of the availability of this kind of data, accessibility, and also the connectivity part. So we're trying to look for more, sovereign capabilities here, not just for the sake of, bragging that we have our own satellites. That's not it. It's really about building industries downstream. This could be companies building terminals, antenna terminals, and radios that communicate with the satellite. These could be companies that process data from the satellites and value add them and use AI and machine learning to to process the data and yield different byproducts, different maps from the data. So that hopefully that answers that question, Dr. Giselle.
I hope we use the ICT, the connectivity thing for productive conversations, not just TikToks. And of course, R&R is also important, but then our population should be educated about this, the potential for connectivity for education and our socioeconomic progress. I'm going to hand over the floor to Alvin.
Hello. Joel, can you hear me?
Yeah.
Excellent talk about opportunities that PhilSA can bring into our economy. One of the challenges Giselle has mentioned is always our local capacity. I know you are you're building the capacity of our space, very specific space technology domains. But what opportunities are there for our local universities across the country to help build and accelerate, the development of the ecosystem, the local space industry ecosystem? We might be losing our own trained people, to other countries. So we have to be prepared for that eventuality. So what are your plans to capacitate our local universities to ensure that we have capacities in Mindanao, in Visayas, in the northern part of Philippines, where most of these applications are very much needed? Joel?
Okay. Thank you, Dr. Alvin. That's a very important question. My answer to that is this. The approach or strategy, if you will, is really, you talk about losing people, other countries that you've trained. The impetus, therefore, is to strengthen local industries. You strengthen universities, yes, but where do these outputs go? Ideally, they should be absorbed by local companies, by local industries. They should be going on to companies in the Philippines doing the innovation there. So our approach, if you will, as you see here, of course, the students still get to build these small satellites, but we want them working with these companies to build them together. And that way, you're also capacitating companies. And because, what for you propose a new degree and have an academic program if then the outputs of the graduates do not end up getting jobs locally? You're producing, but so that's why our approach is to strengthen local industries, SMEs even, very important, small, medium enterprises. They have a part in the global space economy because they could be doing welding, they could be doing soldering, they could be doing polishing of mechanical structures. It's important in that environment. So that's the approach. And that will pull the universities, and feed back to the universities and also helps universities. The space agency doesn't have a lot of resources in the Philippines right now. So whatever resources that we have, we try to direct them, and agency can utilize them, and we want to connect them to industries as well. Yeah.
Thank you, Joel. And I think I hope the PhilSA is able to identify key. We cannot develop the entire, we have different problems for different parts of the country. So anyway, thank you for that. My second question is about energy. What innovative solutions can space technology offer energy problem?
that's a very important concern. Our president mentioned he wants 100% electrification. Might be within reachable by the grid. You can connect them, but those outside not reachable by the grid, you put solar panels or other sources. Now, satellite imagery can help maybe enforce the efficient implementation of programs such as electrification, because this is infrastructure. I'm not saying we can detect transmission lines, maybe not that, but I mean, solar installations that are maybe large enough as a community solar, in terms of monitoring the implementation of infrastructure projects, algorithms are built to detect this infrastructure so that resources are not wasted. That's the paradigm with the project with DBM, wherein satellite imagery is being used to monitor the implementation of infrastructure projects and flagship projects by the government under Build Better More, so that roads, airports, etc., and other infrastructure. This can be a topic that's discussed in extensively at length, but there's ongoing
Okay.
satellite imagery to support renewable energy sources baseline.
Thank you, Joel. Giselle, there are already people raising their hands.
Yeah,
Go ahead.
and maybe, ideally, renewables to 50%. Now we're at 23, moving up to 35, and ideally it should be 50-50.
You want to 50%.
Drilling to find the new reserves of our natural gas and our oil, natural gas. Anyways, that's
Okay.
for another invite, Joel. We'll surely invite you again. But at this point, I'd like to open the floor to our guests, and I see two hands. One first from our PAASE president, Dr. Mario Santo Domingo, and then second would be our UP ERDFI Executive Director, Tito Aliga. Mario?
Thank you very much, Giselle. Thank you very much, Dr. Marciano, for such an enlightening talk. I'd like to represent, the young students, young professionals in the audience who may have some interest in engaging the Philippine, space agency or venturing into space-related career, but who may not know the entry point, like what training does someone who has interest in space science need to do? Because I don't think we have like space science programs in our universities, right? So can you please describe, what kind of training and competencies one would need in order to be a space scientist or someone who can work for you and to contribute to the innovation related to the space ecosystem development in the country?
Thank you, sir, for that question. And again, happy to do this talk and happy to do another talk. I guess the answer to that question is, well, pretty much I can draw from my own. I'm not a space scientist. I'm not a space engineer. I didn't have that formal training. I didn't do an undergrad degree or even a master's or a doctorate degree in space. I am an electronics engineer doing wireless communications. I think you just need to be a good scientist and engineer. You use your background, whether you come from chemical engineering, materials, mechanical, industrial, computer science, material science, physics, chemistry. We use that. In fact, I don't know anyone right now in PhilSA who really has that formal training from undergrad that's focused on space. They come with their physics background, they come with their chemistry, biology background, and they start applying, learning new things. Of course, I guess with the formal training, things can get accelerated. But these young people, they're very eager to learn new things. So I guess the eagerness to learn, that empathy to work in the team and being able to understand the constraints of what you're building and working with others to power through those constraints and build something bigger than what you can build by yourself. It's that T-shaped mindset where you're very strong in what you have, whether it's chemistry, biology, physics, engineering. You have that vertical, that I, but then you need that span, the T, where it allows you to work with others and have that teamwork and I mentioned empathy and that being able to see the bigger picture. that way you solve societal problems rather than focusing on some narrower. But that's important. You need the vertical part, but we need a T-shaped people. So yes, right now the answer is you can be from any discipline in science and engineering and work for the Philippine Space Agency, because evidently that's what happened. That's what's happened with us. And we also need very good communicators. We also need very good people in policy. We also need people in economics. Because we need to translate these science and technology, the things that we're doing, into these socioeconomic parameters. We need social scientists in the space agency. They're all welcome. I just hope we can hire them more. But as I show you that mature ecosystem, I think that connotes that someday the space agency will kind of shrink, because you lose people. You don't mind because you're losing them to local companies. You're losing them to local institutions.
To
You're
say
losing
that
them to universities.
Joel, we have 3 members of PAASE who are NASA. They were at NASA. Well, Joey Comiso, who's visited you. There is Joel Cuello, who was in NASA, bioengineering systems. And then we have, of course, Greg Tangwana, who has experience in designing MEMS, right? So we have this wealth of experts in PAASE who can actually start training relating to space. Okay, so at this point, I would like to call our executive director of the UP ERDFI, where Joel belongs as one of the outstanding engineering graduates, to speak. Yes, Tito.
Thank you very much, Giselle. Thank you very much, Alvin. I wrote something on the chat message, but my question, Joel, was how do we enlist companies to become part of your industrial effort? Like right now, from your presentation, you have about 10. I know one of them, embedded silicon of Bongbinges. How do they get involved, and how do you have a checklist of what needs to be designed and built? And then what are the incentives for them to join you in that effort?
Thank you, Tito. Well, we kind of do a roadshow. We do it by reaching out. Our engineers and people in the space agency went out in the past couple of years, going to their factories, meeting their engineers, not just their engineers, their managers and the executives, even talking about the programs. First of all, familiarizing with these what they do. So it's been kind of confined so far to the extent where we can go out and meet them. But the plan is to organize. We did some online webinars. We extended the invitation to members of I think AAPI, I think even SAPI, and the Aerospace Industries Association of the Philippines, headed by then John Lee. So some of them responded. So we do this, and we'll keep doing it, and then we'll keep visiting them. And then through that dialogue, we learn more about what they're doing, and then we see how adjacent they are to space. And then see, where you do this test for your product, it can be space qualified, and then it opens up a new market for you. Because the space agency will not be manufacturing things. We will be customers eventually, and we'll focus on the missions. We'll focus on the high value data and all of that, and the new instruments and the new technologies that can go in there cascaded to companies. So that's what we can do. Yeah, we'll keep doing this online seminars. We'll keep visiting them and expand the base. And we appreciate the help of UP ERDFI.
Thank you, Joel. Thank you very much.
Thank you so much, Tito and Joel. And I think having Joel at the helm of PhilSA is really great for all of us. I wanted to mention that he was also our research program manager of the PICARI for long time. So this is great experience, and he knows the people from academia. But now I think it's so important. There's a lot of innovation that's going on in the bigger to medium-sized companies, as we know, Tito. And kids PIDS survey of 2021 documents this, but we need to get more MSMEs and startups also to help. And there's not a conflict there, Joel and Tito, because I think the MSMEs eventually could become interesting to the larger companies for a merger and acquisition. Okay, so
Thank you, Giselle. Thank you,
I
Joel.
don't see any more raised hands, are there, Alvin? I don't see any.
Yeah,
Anybody
no,
wants to
not-
speak the
not
floor
one.
right
Okay,
now?
let's just ask Joel while we're waiting for some questions on the floor. Joel, if you were to focus on a particular area on the application space technology that will bring the biggest impact in the short term, what will that be?
That's already underway. It's really the downstream data mobilization. If you talk about really near term, that's kind of already happening. Even before PhilSA, with efforts of DOST and ASTI and the universities, it's just an additional source of data, these satellites.
Okay.
So it's really, I guess, the more impactful one is not to push, but for these groups to start pulling. And the impactful thing is to build capacity within other agencies so they can start processing data and making analysis of the data and making actions out of the data. And they will start pulling the data from you. So that's the priority on the downstream. But as mentioned, we cannot really lose sight of also the source of the data, which are these cameras and payloads and the satellites themselves. We have to have mastery in those technologies as well, because the data is like water. It comes from a faucet. You turn on the faucet. You don't care about the plumbing, but those that control the plumbing, they determine the water, the volume of water you get, the quality of the water, the price of the water. So we have to be conversant, not just conversant. We have to be equipped as well.
Yeah.
Young people. Plumbing.
Joel, just a follow-up. In our research and development in this country, data has always been, a major issue. So, how can you assure our researchers and scientists that they can access these satellite images and data from your agency without much bureaucratic and difficult processes to access this data for research and technology development?
Well, if it's these universities and for research, the data that the space agency has, including the ones that are still with DOST, because my former agency ASTI also holds a lot of data. We can also request them, trying to consolidate that, of course. This will always be available to the universities. I think it's a simple matter of registering, I guess, or sending an email and then identifying what areas of interest. Maybe the difficult part is, first of all, I guess, trying to streamline the process of getting the data based on your specifications. There's some iteration there sometimes, when you need multispectral data, what kind of bands, etc., the areas of interest maybe need to be better defined. But otherwise, there's really a conscious effort to get this data in the hands of researchers, without much fuss. So we are, it's still work in progress, trying to professionalize and make this process more efficient. But we're an email away at the moment. So yeah, just
Thank you.
I know also you also have some requests.
I'm attest to that.
Okay, hopefully we can get your thank you.
Thank you.
Before we ask the last question, Mr. Cabellon's hand is raised. I just want to follow through of what Alvin said, because I have firsthand information from his mentee, Marvin, in Eastern Visayas State University, that he could only access a fragment or a part of the LiDAR data on flooding that was developed by the DOST then. Okay, and Marvin is really seriously looking at the flooding problem in Tacloban and the rest of Leyte, and he cannot access it anymore. So I'm just curious, what happened to that data from the mid 2015s, 2014, and what's the IP? I remember there was an IP issue there. Just a quick answer, Joel.
Yeah, Unfortunately, Dr. Giselle, I'm not familiar with where the LiDAR data is. I think Dr. Eric Paringit and his team then would be in a position to answer that. These are projects, I think these are outputs of the DREAM LiDAR project. We've benefited from that as well, our work in the space agency and also with the Microsat program. But yeah, I can relay also the question, but if the satellite imagery is also needed, because the LiDAR, I think, is based on the airborne platform, you know.
Yes, but I think that you should ask the president, office of the president, maybe to instruct the UST to transfer that to you because you're now PhilSA, right? But
yeah.
sayang naman yung investment ng UP at ng UST doon sa LiDAR data na yon on ano.
I had a reply. There's a phone a friend here. Somebody mentioned to me the LiDAR data can be requested from the UP Diliman TCAGP. I'll give this is the training center for applied geodesy and photogrammetry. Baka lang may issues on the portal, but the data can be requested. There's an assurance here from a colleague from UP that.
Bakit naman may issue sa portal ang accessibility? I remember saying levels of accessibility yan, access to the data. Anyway, everyone can connect with Joel. He's very accessible and he's very friendly to us. So thank you. We'll call Dr. Billy Cabellon now, who's been active in our conversations, always in past. Thank you.
Very much, Dr. Concepcion. It's nice to see Dr. Marciano. I'll keep my question simple because this is not my area of expertise. In 2016, Secretary Guevara was on his way to Florida to I guess notice the launching of the first satellite of the Philippines. Now there have been several satellites placed up over, I guess, the Philippines or so. So my question is very simple. What benefit has the Philippines gotten from these satellites? It's a simple question, but for a layman like us, you know, anong nangyari? Anong nakuha natin sa mga satellites na nasa taas ng Pilipinas?
Thank you, Dr. Cabellon, for that question. In some of the slides in my presentation, I think I showed how the local industry engagement is really a prime feature. You know, apart from building competencies of young people in the Philippines in building difficult things that can work in outer space. Which, by the way, if you're trained for that, those skills are important across a wide range of high-value manufacturing industries. You don't really have to go just for space. You know, parents ask us that if my son or daughter is trained for space, isn't their options limited? No, you can work in other high-value manufacturing industries and design industries as well. They're highly sought after. So yeah, apart from those skills, it's really building this nascent capabilities in the country, particularly industrial capability. You know, our economy is dominated by services and of course remittances. We're trying to build industrialization, the manufacturing part, and space also opens the door for that because it's becoming more accessible.
Yes.
And so these satellites might be small. You think they're not very capable, but they're very powerful in the sense that they carry Philippine components.
All right.
They can carry Philippine components. Yeah.
That's a nice, quick answer.
Thank you.
So our very last person to ask the question is Dr. Gil Mendoza. We're it's time, so Gil, please.
Yeah, thank you. I do have also some interest and concern about the sharing of the data. And I hope that it will be a lot easier to access compared to our experience with the LiDAR data. Anyway, my question is really quite simple. What's the special resolution of the satellite data that could be provided by MULA?
This is 3 meters resolution, in 3 to 5 meter resolution multispectral data.
Wow, that's good. Thank you very much.
Yeah, thank you.
Okay. All right. If there are no more questions now, Alvin, We had a rehearsal or dry run yesterday, and I'd like to thank Feb, who is so important in all of these events in PAASE. And we thank our President Mario for supporting this Fireside Chat series. And I'd like to thank my co-host Alvin, and most especially our guest Joel today, and all those who asked questions. I'd like to say that this is ongoing. We'll run it for as long as we can. I have this endless list of speakers, and well, you could suggest to us more speakers. As I said, not just from government, but many more from government, also from universities, from research institutes, from startups, and SMEs and large industries, foreign-based ones as well, and also from venture capitalists, and also from media. So I'd like to announce this schedule. Our next speaker will be Dr. Tirso Ronquillo, President of Batangas State University and President of the Philippine Association of State Universities and Colleges. You cannot imagine how impressive the university has built in Batangas City and the adjacent Knowledge Institute of Science and Technology, KIST. First, knowledge
And innovation. Innovation.
Art, okay, and for innovation.
Technology.
Yes, and we visited the site. So there are also many technologies there now. So please join us again next Friday. And the format will be this way. It's informal, but very informative. Informative. And now I'd like to move to the next. Well, we'll introduce Elmer again next week. And afterwards, Homer. And it's going to be like different topics. You know, it depends on availability of our speakers. So we're not going to do thematic a month, because we might get an overdose of one theme, right? Please, may I then move to the last slide? And here in PAASE, we have taglines, some of which would be Agham at Kaalaman para sa Bayan, constructive SNT-based volunteerism to Philippine regions. So we really want to help the regions. We don't want it concentrated only in NCR or in Cebu or the premier cities. Okay, but of course that's the natural course of development. So actually, as a executive member of the NIC, I have actually, with the blessings of our PAASE president, I have a form for a capsule concept proposal, okay, a grant proposal. We will not show it here unless you have time to look at it. That is based on what's published or posted in the NIC website. But then, the funding from the NIC is shifting from type of a grant to an ROI, revolving fund. Next year, it will have to be with an ROI or a revolving fund, meaning it might be a very nice small interest loan. So it will really select or filter only those that are at the innovation stage and not just at the R&D stage. Okay, so this is for all, open for SUCs and government agencies. We are really hoping that it will eventually be open to the private sector. The second is something that we have really been doing in PAASE, which is to come up with position papers, white papers, or concept notes. Okay, so relating to innovation, anything at all is related to innovation. How we are going to do STEM, K-12 and tertiary education that is innovative. So there is already a group in PAASE that is trying to come up with this. So you're free to to send it to your favorite Congress or Senate legislator, or if you want it directly to the NIC, to the Office of the President. This is also one venue. So I think scientists, innovators, engineers should have a greater say. And we may even also consider maybe social and public media, print media, because there are columnists who are almost devoted to STI topics. One of them is Buchanko, who has been a guest in PAASE in the past. Third is this: we welcome, your first-hand accounts, your ideas on what you've experienced as barriers to innovation, your barriers to innovation, and what your proposed solutions are. And this, we think, would really be under the purview of the executive members of the National Innovation Council. We may be forming a technical working group on this. We know the heart of it is procurement, but it's not just procurement. There have been many studies on procurement, and now we need to address the other barriers as well. And PID has also identified some of these barriers to innovation in the academe as well as in the private sector. So with that, I think that we are almost at the end of our fireside chat. I'd like to then give the floor to my co-host, Dr. Alvin Tulao. Thank you.
Thank you, Giselle. Again, thank you so much for this opportunity. You know what, guys? I'm here in Hanoi, domestic airport. In an hour's time, I'll be flying to Ho Chi Minh on my way back to the Philippines. So again, Joel, thank you so much. This excites us all, not only in the scientific community, but our industry, which is very important.
Correct.
The downstream, benefits of the PhilSA is we need to focus on, I think, because once we build our scientific capacity, we should have places to absorb our highly technically trained people to build a robust local space industry ecosystem in the country. So once again, we wish you all the best, Joel. We'll bring you back sometime soon.
Dr. Alvin, can I just take 1 minute just to acknowledge the people who helped me
And
with this
to all the
presentation?
participants who are here today and on our live stream on Facebook and YouTube. Thank you so much. Giselle has already provided information on how you can get involved, as an individual, as an organization, or simply as an enthusiast on space technology application. Reach out to PAASE, and definitely we are here, to engage you. And Mario, our president, I think has always been our socially, social advocate to engage everyone in our innovative, advocacies to solve the problems of the country. So once again, thank you so much, Giselle, Joel, Mario, and everyone. Of course, Tito and
Thank
everyone. To the universities represented here. We'll see you in the next Innovation Fireside Chat, where we will now engage Dr. Tirso Ronquillo.
Ronquillo.
Dr. Alvin, Dr. Giselle, can I just acknowledge Dr. Jing Soriano,
Sure.
Engineer PJ,
Joel,
Dr. Mark Talampas, there you go. These people have been instrumental in this journey. Alvin Rotamar, Dr. Gay, of course, there are many engineers. Lure Labrador is here despite the cancellation of work. They're here in the office right now, making sure that this presentation goes well. I just want to acknowledge them. It takes a barangay, to run a space program.
The village.
And this is now, this is a new age balangay, where we're going to space, to be a space-faring nation. Is we want to help lift the tide, bring the waves that lifts all boats, essentially to space capability. And I want to acknowledge these people and many more. Thank you very much.
Thank you, Joel.
I'm
Thank
happy
you,
to
everyone.
see
Can we have a group picture?
Yes,
Can we have a group photo?
On your camera.
Yeah, so we'll do we should do the a gallery, remove the spotlights now, Fab, and we'll do the group photos. Thank you. There.
Thank you, Mario. Thank you, Doc Billy.
Thank you, everyone. Thank you po.
Okay po. 1, 2, 3. Smile. Page 2 po. 1, 2, 3. Smile. Last page po. 1, 2, 3. Smile. Done na po.
I'd
Thank
like
you.
to recognize, now I see everyone, VP Gladys Completo, our president-elect, who will be
Gladys.
our annual conference in
Hi, Gladys.
Los Baños next July. Thank you.
Thank you.
Thank you, Gladys.
One,
Okay.
Salamat
See
po.
you and
two
bye for now.
meetings going on.
Stay safe and warm, everyone.
Okay.
And
Bye-bye.
Thank you.
Bye-bye
And I-
from Hanoi. Joel, thank you.
Thank you.
Giselle, bye-bye.
Yes,
Bye.
bye-bye. All
Thank
right.
you, Giselle.